And now, here's your hosts, Al Martins and Stephanie Bate.
Hey everyone, it's Al Martins, and Stephanie Bate is in the background, as it were, at the moment. This is our first Cutting Time podcast, and we're excited about it. We decided that we've been in the industry long enough that we could handle a podcast that would talk about the industry in an intelligent way and bring some insights, I think, to all of our viewers and customers and industry leaders alike. So we look forward to working with you all and talking to you about what is happening in the world of CNC. So today, my opportunity is to share who's Stephanie and who is my co-host. Stephanie, well, let me bring her on and I'll let you hear from her what she's doing in the background.
I'll click the same button. Yeah, hi everyone. My name's Stephanie. I'm the kind of coordinator of the podcast / co-host. Yeah, I have a background in video editing and social media, so this role just called my name, really. So I'll be in the background watching over everything, and yeah, I'll pop in sometimes.
Great. We'll bring you on once in a while. Stephanie, just as a side note, this is live. So, yes, everything you hear and say and do will be, in fact, streamed out to you real time.
Mm-hmm. We have 3 people watching.
Oh, excellent. So, Steph, I guess they'll be able to leave comments on their Facebook or LinkedIn or YouTube pages, will they?
Yep, and Twitter. So yeah, you can leave comments. We can see them coming in, and we'll try to respond to them as quickly as we can.
Right. So you'll be keeping track of them, I guess. On our tab, it says comments in the corner. Is that where they're coming in?
Yeah.
Okay. So for those 3 who are logged in, maybe you can send hello just to make sure it's working. Seeing as this is our first podcast, maybe somebody can say hi from one of those platforms. Mm-hmm. Hi, Mom. I'm sure she's out there somewhere. Well, thank you, Steph. I appreciate that. I mean, certainly you can stay on for the moment. I am really honored and pleased to have our first guest to be Luis Ruivo, or Luis Ruivo, as some of you may know him. He's no stranger to me. I've known him for over 30 years. Excellent business partner and certainly associate. Couldn't ask for somebody better. And he was kind enough to be our first guest on our Cutting Time CNC Industry Podcast. So we're going to be talking today and taking a deep dive, as it were, into the CNC basics, trying to understand a little bit more about what it is. Our podcast is going to cover all kinds of topics with all kinds of guests. We'll be doing this every 2 weeks. So it'll be changing up all the time, and at the outro, you'll be able to listen to it on Apple and Spotify. Am I right there, Steph?
Mm-hmm. Correct.
Great. And on the video format, you'll be able to see it on all the places you've just selected. So YouTube, Facebook, Twitter, and
LinkedIn.
Wonderful. So let's introduce Luis. I'm going to bring him on here. He's going to tell us about himself. We're really excited to have him. Thank you for joining us, Luis. Are you bringing him on, Steph, or am I?
I'll bring them on and then I'll exit.
Exit stage left.
Exit stage left.
Ciao. Hey, Luis, welcome aboard. Thank you for coming and joining us on the Cutting Time Podcast.
Thank you, Bud, and my dear friend, Al. Yes, I think it's going to be a fantastic area to discuss and review matters in the manufacturing area. I think we're both passionate, and we have certainly a community around us that has that passion too. So yeah, thank you for bringing me in. It's really an honor to be your partner and to be with you for so many years. Really, yeah, enjoying the pleasures of manufacturing.
Yeah, I agree. Being podcast one, somewhere down the line where we've done 40 or 50 of them, we'll come back to this first one and have a look and see what it was like. And hopefully these will stay in what do they say, perpetuitude, in perpetuitude. That's a Stephanie question. She might be able to answer that. But Luis, tell the audience a little bit about yourself, where you come from, what you talk about in relationship to the CNC world, and since we're talking about CNC basics, we've got a few years of experience behind us to talk about that.
Yes, I mean, I guess the gray hair attests to some of it for sure. You can't really say it because I can't see your gray hair, but that's fantastic.
It's smooth today.
It is smooth today.
This is my summer look.
Yes. Yes. Well, I mean, my background is fairly simple. I started in manufacturing back in the old trade school times, where we would still learn how to make parts by hand and understand all the characteristics of materials and feeling the cutting. I did that actually back in Portugal, the technical course, and then I came to Canada for vacation, and I fell in love with the country, and I basically came just not even a year after as a machinist, really.
That must have been summertime.
Yes, it was summertime indeed. That's okay. But yeah, so my background was basically machinist. I did go to university, but that doesn't really matter for the matter here. But I've always been passionate by automation, by CNC machining, as you have, and we were, I think, privileged by having had the chance to follow really the early evolution of CNC machining all the way to today. There was so much change, so much evolution. It was absolutely fantastic, how we started from, the early days. So, yes, I did start in the beginning, actually, when I came as a machinist here. And very quickly, I started my first company, CNC Technologies, doing CNC consulting, actually, back in the days, how to operate CNC machines, how to program them, set them up. And then, believe it or not, the first software that I started with was SmartCam. Back there was, one of the early ones, actually, SmartCam, along with GibbsCam, back in the 80s. Back in the day. And started with SmartCam. Actually, the first integration I did was on HP Unix workstations.
Wow.
It was something at the time. I believe that the workstations at the time were somewhere around $40,000 US, and the software wasn't very far from that either per station. It was
Probably
really
not much faster than an iPhone.
Well,
than one of today's iPhones.
Oh, exactly. I mean, it's a completely different ballgame. And and then from there, I started my first company, CNC Technology, doing that type of work, and basically I've been in the area since, really. I mean, we have been following and developing technology. I was, involved in developing actually code for CNC programming, not CNC code per se that I've done, all my life, but mostly developing 5-axis algorithms. Early instigator of robot machining, actually, using robots with end mills to machine stuff, stones and foam, and other areas of exploration that are, absolutely passioning. But realistically, even from the beginning, if we look at it, going from the basics of or making parts with using manual machining into the CNC machining was already fascinating, and that field really I was something that I always loved with passion. And that created basically this interest in growing in this field. And as you know, because obviously we're partners and we have developed a number of technologies ourselves and trained a lot of people in the industry. And the realization that I come to every day, as in life in general, every time we meet someone, we learn something new, a new way of cutting this type of material on this type of equipment. There is so much to be learned still, but the evolution is absolutely interesting, and we can talk about that a little bit later. I mean, I think the subject of today is an introduction, but it's absolutely fascinating how far we came along until today.
Yeah. Well, I agree. Like you, I started back in the 80s, and we're still in it today. And the technology has grown and grown and grown, and there's just so much there. The interesting part is, how do young people get started in the industry? How do they get passion? Because certainly most schools don't encourage trades. They don't encourage this type of working with your hands. It's a really sad thing, when here in the States and Canada, when they decided that shop classes were no longer necessary, the very things that could make people productive. That's a whole other topic, and we'll talk about that another time. But certainly, getting people interested in cutting metal, cutting wood with CNC machines is fascinating. And the whole podcast name, Cutting Time, is a play on that. And certainly from reality, working with machines in the old days with the cranks, which we learned how to do, there is a place still for those. And it's a great place to learn, to understand the sound of the metal cutting and the vibrations and the interaction between the machine and the metal and the human are, I think, a real good play on a good CNC programmer operator. So along those lines, Luigi, I mean, obviously we have the background. You certainly have a rich history of working in shops and helping shops. So, if we had to explain to somebody, CNC machining, how it differs from traditional machining, is that something maybe you can touch on a little bit?
Well, yes. I mean, how can I say? I mean, basically, CNC traditional machining. Obviously, it's are going from traditional machining into CNC machining. It's almost like if you were basically riding a bike and jumping into a electric autonomous drone, right? So there are two separate worlds in there, but obviously there is a correlation, because if we look at the metal removal process, and obviously manufacturing has come into or CNC manufacturing has come into something beyond just the removal, because we are now actually adding material too. But if we talk about the basics, the CNC machine is basically a similar equipment that we used to control manually before, but now using the ability and the power of the electronic technology and the computer technology, right? So when you look at a CNC machine, system, you have basically controller, you have drivers and motors, you have the machine interface, so an interface that allows the user to interact with the equipment and send the instructions or program the instructions, and then to wrap up, you have basically a feedback system that reports back to the controller how the machine is performing, and this whole dance is all controlled by basically computers that execute instructions. Let's say like you provide the drawing to simplify it, okay, and basically the machine is going to follow that drawing or that map to with the instructions that we gave it, and produce a part, or produce a portion of a part. So a CNC machine is basically a computerized conventional machine. Now, nowadays, it's far more than that, because technology has evolved dramatically in different directions. But in a nutshell, it's basically, a system controlled by a computer with electronics.
Yeah, I think for those who are beginners in that kind of thing, a lot of people are getting into 3D printing. And in 3D printing, you notice that there's a lot of discussion about the system outputs the G code to the machine. So, that G code came from somewhere. And in the 3D printer world, a user brings in an STL model, or they bring in a solid model of some type, and obviously they put it through a slicer and it does its thing, and magically it sends out the code, which they call G code. And certainly what you're talking about, CNC machines differ from that technology, just like 3D printers do from CNC machines. But they all have some relation, and they all have some tie-in. Certainly the first ANSI machines were player pianos. And, those had cards, and those cards, not much different than paper tape. They had a bunch of holes, and it played the note based on where the hole locations were.
Exactly.
So,
well, in fact, you remember those, the ones with the connections, like the old phone systems, right?
The Moogs, the old
exactly.
Moog.
Yeah. So that's where we started. Yeah.
Oh, plug it in here, plug it in there.
Yeah.
And big giant dials. Yeah, absolutely. So I guess, in relationship to that, what do you think the key components are? What are the key components to a CNC?
Well, I mean, again, if we simplify it, because obviously there are a number of things, and it can be very complex. Nowadays, I mean, we have very complex systems. But in a nutshell, it is basically a structure, depending on the type of machine, because you have milling machines, you have lathes, you have mill turn machines, you have MTM machines, very complex multitask machines, Swiss machines, laser machines, you have wire EDM machines, robots really that do CNC machining. So depending on it, the structure might be different, but the basic components are still similar, right? You still need basically a structure for the machine that is composed of the axis and the physical components that are going to move. You're going to have a controller, basically. You have all the electronics, the drives and the motors. And then you have, basically the attachment systems that you're going to use to hold the parts in some way. And the system that holds the tools, or the cutting system that we're going to be using, or the adding system that we're going to be using to generate the part. So if we were talking about this, I'm going to say 15 or maybe 20 years ago, I would be limited to the cutting, right? And I would give you the analogy that we started, that it's a very advanced prehistoric method of manufacturing parts, because we used to, in the prehistoric times, remove material from one part with another part. Well, machining is very similar, just with much more advanced tools and much more advanced materials. But nowadays, because of the type of equipments and technology that we have available, like laser cutting, water jet cutting, EDM.
I think if we just boiled it down, we have typically, I say loosely, for a 3-axis machine, we need 3 servos. We need 3 servo motors. We need a control, just like you said, and one feedback system, maybe a spindle drive if you're lucky, and it will tell you where to turn the spindle on. But basically, not much different than a 3D printer. Something's got to tell where things move and how it moves. So which brings you kind of into what we were talking about in our third question, which was, what are their respective applications? So if we looked at CNC today, I mean, we have CNCs for just about everything. I mean, it was not that long ago we started doing water jet. Before that, we had plasma cutting, right? Before that, we had certainly 2-axis milling. In the early days, we had, I think it was Bell Helicopter initially started NC with the profile of the helicopter blades. So you have a lot of experience with machines that people are just getting their hands on right now, and that's 5-axis milling and multi-axis turning. Tell us about those applications.
Well, those machines really brought the manufacturing process into another level of productivity, right? Because one big thing about CNC machining is our ability to make very precise, much more complex parts much faster. All right. So before, to make a part manually, you would probably require a number of setups on different machines, and each setup was much more complex because you were limited to the abilities of your rudimentary equipment. Nowadays, with 5-axis machines, I mean, you put a block of metal into the table of the machine, and you basically finish the part. Most of the time, regardless of the complexity. Now, I'm simplifying. I'm maybe oversimplifying,
Yeah.
but the ability that these configurations of machines, and when we talk about 5-axis machines, for just for clarification or maybe instruction, 5-axis is basically what? It's 3 linear axes. That's the basic concept of 5-axis, right? 3 linear axes and 2 rotary axes around 2 of the linear axes. That's the most basic 5-axis concept for CNC machining. Now, those axes, they can be distributed differently depending on the configuration of the machine. Traditionally, and I guess where we started, mind you, Uran heads were the old Uran heads that with Uran configuration that we know today, and we use it often in 5-axis. They had the 5-axis on the head, but we started most 5-axis operations and the common 5-axis back in the days when we started doing 5-axis were table configuration, which is basically a rotary axis on one of the linear axes on the table. So an artifact that you install on the machine that allows you to rotate in 2 different axes. So because of that, now we can put a part on the machine and we can machine all the way around all 5 facets of the part. And a lot of times we can even go behind the part and machine whatever is left to finish the part. So these capabilities not only allowed us to make parts much more efficiently, because any time that you're not moving a part from one machine to do another operation, right, you're reducing the cost, but you're also doing something that is excessively important, which is increasing precision. Because to maintain tolerances, when you move a part from one machine to another, you need to have a very precise setup to be able to make sure that you're respecting, the geometric tolerances of the part. Because you're not moving the part from that setup, and you can do everything within one single hold, well, you basically eliminate all the additional costs related to additional tooling, the costs related to moving the part from one machine to another, and so on and so forth. So,
I did tell you this was a 1-hour podcast, didn't I?
I mean, we could talk for hours, of course.
I know. We on every one of these questions we could go on, but ultimately, yes, multi-axis and 5-axis systems are becoming really popular. And when I say multi-axis systems, today there is kind of a fog about what the machine is. Is it a mill turn center? Is it a turning milling center? What is it? Is it a screw machine? Are they still called screw machines? Screw machines have come into the world of CNC. Nobody's machining cams anymore. to make these things move. But yeah, that's a whole other topic. And when we look at languages, and when I say languages, Luis, I'm talking about control types.
Okay.
When we started in the 80s, things haven't really changed that much. Did you want to touch on that a little bit?
Well, I mean, we can start. There are basically two paradigms here that we can talk about. One, which is the language that basically constitutes the language or the instructions that we transfer to the machine to execute the part, or give the instructions to the machine to execute the part. And then there is another level of language, which is basically instructions that will be converted into the machine movement instructions. Let me clarify. So we have the most basic one that we started programming by hand, which was GNM codes, when we started writing, those codes. And that's, the most basic programming language, I'm going to say. But, when we started programming, there were languages that started appearing, like APT, CL, cutter location, right? And because that is basically a neutral language that you would then convert using a post processor into the specific language that is required for a specific machine controller or configuration, right? And this is a very interesting area that deserves on its own podcast, because I think it is an area that is not only very interesting, but very critical to the manufacturing industry, and somewhat a lot of times not regarded with the attention that it should get, because the ability to have good code, good instructions, makes the whole difference in the ability to use a specific equipment productivity and efficiently.
I think if we boil it back again, seeing, it's kind of rudimentary. If somebody was saying, what type of language do I need to learn to program a CNC machine? It really goes back. If you looked up online G-code programming, that's going to cover just about every control, because ultimately you can look at a FANUC control, which is, I think, predominant in Asia and North America for sure. Siemens, I'm going to say, is predominant. I don't want to say predominant, but Siemens certainly is popular in Europe.
And Heidenhain.
And it's a G-code based system. Heidenhain has their own conversational system, but it'll still run what they call ISO, which is also known as, the standard G-code system. So yeah, if you had to learn, and certainly 3D printers, if you had to rudimentarily learn how to write code, learn G-code. And I would say they're almost all interchangeable. There's version A, B, and C. They're slightly different. G20 is inch, G70 is inch if you're in the C coefficient, but they're pretty much the same across the board. So if you can write that and learn that and write a few programs by hand, I think you'll be in good shape with any control, most controls that you'll come across. Would you agree?
Well, I agree 100%, but you touch there in a very important point, which is basically the learning process of becoming a proper programmer or even an operator. And one of the things that unfortunately we've seen in the industry is kind of diminishing the importance of understanding the fundamentals of manufacturing before you get the person into a higher level of programming, for instance, or using an equipment. Understanding the basics of machining is fundamental to become a good programmer. And we can talk about AI and all that, but the reality is, and not longer than this week, I was at a customer helping him with a new type of process on a machine. And the ability to understand the G-code actually allowed us to go beyond what was the pretended or offered approach to execute that type of operation. But the language in itself, it's not overly complicated. But one needs to understand what those codes are. And I agree with you. Understanding G code today, if you're interested in manufacturing and CNC machining, I think you should start at that base, understand it, because it really covers the whole spectrum of manufacturing. You can program a 2-axis router or a 2-axis lathe all the way to a 32-axis Swiss style machine if you understand G code, right?
Yeah, no, absolutely. And again, that's another topic we could go down the road with. But as a operator, let's say, even just a CNC operator, when you're there and you're in front of a machine, look at the G code, look what's happening. Because ultimately, understanding it, it's kind of like, we watch these movies where people go into a temple, or they go into some situation where they're looking at hieroglyphics, and there's only one person on the team who can read it. What does it say? What does it say? And by the time they find the guy who's read it, it said, well, if you open this box, you're dead. So, well, okay, little late. And how does that relate to something? Well, if you can read the G code and suddenly it's saying G00 the next few lines, and it's rapiding through the part, you might have a concern and maybe press the feed hold button, and you've saved the company a whole ton of money, especially when you're running a first off.
Yeah, and it is important, because even though today with the advanced CAM technologies that we have, because of this requirement of making the conversion of the geometric information, the toolpaths that are basically graphic trajectories on the screen, that geometry needs to be converted to the language of that specific controller based on that specific machine configuration. It is important, and unfortunately, not all CAM systems output, proper code. I'm going to say, what happens is that potential of error or inefficiency is there very often, and the fact that an operator doesn't understand that, makes this process of testing the first part, as you were mentioning, much more complicated, because now he has to be excessively careful, because he can't read the code ahead and try to anticipate what's going to happen in the next move. So the other thing is understanding well the manufacturing process and the codes also gives the operator that ability to be more important in the whole optimization process, because he is the guy running the machine. And when he is running this machine and he feels that something can be improved, he has now the ability and the knowledge to actually convey that information, to the programming department. Eventually, depending on the configuration of the work environment on that place, they might be able to make changes, prove their concept, and relate back that improvement without having caused damage or diminishing the process that was already there. So that's really a very important point.
So if you look at that, we come really into our next question, which really talks about, what are the steps to get from a drawing to the finished parts on a CNC? What's that like? What is that whole process? And it is obviously that's another whole show, but in short, what's that like?
Well, as you say, I mean that topic alone is a very interesting one, and we could talk about different technologies and different methods, and even automation and optimization of programming. But in a nutshell, basically, in our days, we take a solid model, a model that has been designed on a CAD system, CAD standing for computer-aided drawings or design. So you basically create that 3D geometry in the CAD or in your CAM system, itself from a 2D drawing or some concept. And then based on that geometry, you define the process that you're going to manufacture this part. It could be one step, it could be multiple setups on different machines, depending on the complexity of the part and the equipments that you might have available to you. And then you basically generate what we call a process sheet. In general, that's what you learn at school, but we always do it even if you didn't document it, which is the method that you are going to progress through the removal of the material in the different tools that we're going to be using in order to achieve that part. So in this case, we would use a CAM system to generate toolpaths, or you would create your own G&M codes program that you then upload to the CNC machine, and basically you remove the material from that block of material. It could be whatever, and it makes a part. The interesting thing, I'm sorry, Hal, I'm going to interrupt you real quick here because of the passion that we have. It's really, I think, induced by the fact that everything that we have around us, and a lot of times people don't realize that everything that we have around us had to be manufactured one way or another. Doesn't matter what it is. So it's such an amazing field that when you look at a glass, you look at a car, the components of a car, and the complexity of those surfaces. Someone had to do that work. Those molds, those processes.
I think that's the lament of people who hang around with engineers. They'll grab something and start looking at it for a while, and wait a second, where's the parting line on this? And how is this made? And then it goes on. But ultimately, I think to your point to the very basic core of setting up a CNC machine is you have a table or you have a chuck. And based on how you created your program, you know where the origin is, where it's set up on the table or where it's set up on your lathe. And based on where you were taught, that will change. Some people take the offsets at the bottom of a part. Some people take the offsets from the chuck forward, and some people take it from the front of the part. But ultimately, you put the part, you program the part, and you put the part on the machine based on the reality of how you set it up in your program, put in the offsets, put in the code, and hopefully you'll have a good finished part. I think that's the basic objects there. So if we jump into the next, and again, it's kind of interesting that this question, is coming after, but I thought we'd build up a little momentum. But in my next question is, what are the considerations really of selecting the right tools for the right materials for the CNC machine? And again, this is a whole, maybe 4 other shows, but in a nutshell, how would you cover that?
Well, see, it is a very interesting topic, a complex one, too, because of course there are, depending on the process that you're going to be using to manufacture or to execute that setup or that cutting process or manufacturing process, I'm going to say, there are a number of considerations related to the way that you're going to hold your tools, the system. And so if we go back, there are some fundamental physics involved in the manufacturing of by removing material. And one important one is rigidity of the system, because rigidity has a direct influence on the life of a tool, on the finish of a part or surface, as well as the longevity of that tool. If your cutting conditions are not appropriate, if the tool geometry is not appropriate, you might not even be able to cut the material at all. The understanding the tooling technology, understanding the way that the tool itself, the cutting tool, is attached to the machine itself is excessively important. And the way that you hold the part to the machine is also excessively important. And because all these elements contribute to that ultimate goal of rigidity. And when you have this understanding, then you can start making proper choices. Now, today we are somewhat privileged because there is a lot of technology that allows us to better calculate cutting feeds and speeds based on machine characteristics, based on rigidity of the holding system, uh, and and there are also a number of different types of tools that allow us to better manufacture parts in different types of materials. And that is actually an area that is, I believe, very important. And we should have a podcast just on that because the
Yeah,
the
we
cutting,
definitely will.
I mean, the cutting or is critical on the whole process. Even if we talk about productivity and profitability, right? A lot of companies are still using methods back from the old days, using high-speed tools, for instance.
Exactly. If we boil it back down again, keeping in mind this is a basic introduction to the world of CNC. Do you need to choose different tools for different materials? The answer is yes. And like you said, in the old days, you basically had tool steel, and you took it to the grinder and you shaped it, and now you were cutting your material. That's what you had. You were cutting steel, you were cutting aluminum, you were cutting bronze. All you did was change the grinding profile of how you took that block of tool steel to the grinder, and you put a trip breaker in there and put the radius on there, and suddenly you would have a different tool. Now we're cutting aluminum, damn it. Today, there are so many tooling manufacturers, and I mentioned aluminum, steel, and bronze, but there are so many alloys and alloy groups of materials that are available. Not quite as many as there are cutting tools, but yeah, this requires a whole other episode. But yes, you pick a different material, you're going to use probably a different cutter profile, cutter carbide, and or ceramic and or diamond. The list goes on.
Even the tool geometry, Albert, it's very critical to the to the results. So that's a very important thing, and that's also why it is important to stay active in the in the technology that evolves so quickly. I mean, there is a lot of development that has been done over the years in new cutting geometries, and it really has a huge impact on the way that the machines perform. On you can cut faster parts. I mean, I remember back in the days, we're talking like 15 years ago, when we first introduced high performance machining, where we took cutting from, I'm going to say, people were cutting still at say, just to give you a reference, from, I don't know, 30 inches a minute, and we moved that to 450 inches a minute. Now, obviously, there is the tool path geometry and the control of the dynamic of the tool engaged, but certainly the tooling geometry in the materials enable that. But if you are using the traditional ways and you're not evolving with the technology as it is, you're losing a huge opportunity to become more performant. And I guess this is why I think a podcast on this subject, or maybe two, is going to be interesting.
Yeah, we'll definitely have a few there, Luis. And thank you for covering that. I mean, really, as they say, it's going down a rabbit hole because there is so much to discuss, even just on one part component, one type of material. So brings us to the next question, because they're sort of kind of related, and the CNC world, what has that done to contribute to the increased precision of components that we see today?
Well, let's put it this way. When we used to do it before, well, obviously the ability of the operator was critical, right? And how we're all different as humans, so human perception was critical. And because of the way that things were made, of course, obtaining the level of precision and repeatability was a far more difficult task than what it is today with the technology, the CNC machining technology. Now, in that we're talking about prismatic parts. If we look at 3D parts, now it's even more interesting, because before it was almost an art. You wanted to make a car wing, or whatever. I mean, in the aerospace industry, making all this was all handmade, right? Yeah, so you have these artists making components, where with the CNC technology, you're basically repeating very complex parts, very precisely, with a very the level of repeatability that really is incredible. Now,
I think obviously, Luis, you're right, but at the same time, I don't want to discount what generations before us were doing. And if you look even at World War II, when they were making all kinds of aircraft and innovations, they never had a CNC machine, and they were making very, very, very high precision parts.
But that's why I'm saying these guys were artists. I mean, these were people with skill. And this comes back to your initial point about the education, where we are discounting the trades. And I'm going to say, because of the subject of our interest, the manufacturing and the CNC machining, and even machining itself, it requires actually a high degree of understanding, of maths understanding, materials understanding. It's actually quite complex, very rewarding intellectually, and very rewarding because of the things that you do. I mean, when you are making airplane parts, a lot of times, and I had this conversation sometimes with operators on CNC machines at big companies like Boeing or Airbus or Bombardier, where the guy is making the part, and when you tell him that the part he's making, he or anyone of his family one day might be flying on an airplane that has parts that he made. That realization is quite spectacular. And you're absolutely right. Before, in the days, I mean, we had artists. These people, they used to make incredible things with the technology they had available. I mean, I imagine the way that they were making propellers for the Titanic or for those boats. This was absolutely incredible, the way that this was made before.
Well, we remember when we were taking our apprenticeship, we used to have to file a square, 1 inch square, to within 1.5 hours with a file.
We had in our adjustment class, and I have those parts still, right? Yeah. Where you have a dovetailed part, male and female, and you had to make it by hand.
Yep.
And no light could go through. And the teacher would put it to the light.
Yep.
And if you weren't good, you start over.
So anyway, to the point, CNC machines certainly have made things much more precise, in the sense that it allows it. I don't want to say the word dumbed down, but we have now taken that level of years of skill necessary to create a part, and hours and hours to potentially produce a part, and brought it and boiled it down to minutes and or seconds to get similar accuracies.
Absolutely. Yeah, the level of productivity really came up, dramatically. And that's we're talking about traditional removal methods. We're not even talking here about when we're EDMing. Why EDMing?
Yeah, and that leads us to our next really question. What are some of the emerging technologies and trends that we're seeing today. What do you think about that?
Well, certainly. I mean, there are a number of technologies, and I mean, one that is probably the most seen or expected is metal 3D printing, right? Which has been around already for a while, but it's not very uh, you know very much used, mostly because of the cost of the technology. The time that takes to make the parts, and the cost and the material even, and there is another level, and certainly I don't want to take it too high level the conversation, but there is a lot of certification on the parts itself, or the manufacturing process, to validate that method of making a part is actually valid for a number of applications, like nuclear application, medical applications.
You're
And
talking about laser sintering, that type of
yeah,
thing.
well, yeah, in sintering, we've been doing that already for a while. Now we're applying it into actual parts instead of just tooling, because that's where we really started that area. But that we have ultrasonic technology, for instance. We have friction welding. There are incredible technologies, and all these things, like simultaneous riveting. So you have basically a skin of an airplane where you have multiple robots interacting together to hold the parts, to to rivet or to do whatever operation, drill and rivet, and hold it in the back, shot pinning with robots. There are a number of and then obviously we have welding. Welding is and if we want to take it to the next level, obviously, just before I go there, there is all the sanding, automated sanding with robots. And usually, traditionally, you would do that with basically pre-programmed programs. Well, nowadays we are basically using vision to adapt the tool paths to the position of the part.
Yeah.
So we don't have to basically what we're giving instructions, but the instructions are being adapted to the part itself. That might be, depending on the manufacturing process, and we can go from very small to very large. One of the complexities of manufacturing very large parts is manipulation, right? And a lot of times, and I remember clearly many years ago, when we used to do blades for a huge turbines, the blade would be put in onto the machine and then located with the theodolite and then brought back into the cam system to position. Well, nowadays we don't need that anymore, because we can make a program, the machine will, and with the vision system, we can adapt the position of the part and the position of the program to the part, and basically do just adaptive manufacturing, really.
With all the digital twin stuff coming out, and basically every segment of our lives, especially in this, we'll say this last couple of years with AI being introduced, they're finding ways to automate the automation. Yeah. And taking the human element out of the process. And again, that's another whole discussion. But if you have a bunch of humans that aren't really motivated or willing to work, who are not motivated, self-motivated enough to want to be in build something or create something, the human race needs to continue. So we are finding ways to make things without humans. And that includes, I mean, there are restaurants who are creating kitchens with robots. And soon, it's not that too far down the road where we'll be going into a fast food joint, which won't have potentially any humans. It might be an AI who takes your order and robots make the food.
Well, right now it's kind of a romantic thing, and you saw it in Vegas, where you have the robot making, mixing the drinks and serving, right? Yep. And I mean, we ourselves, we have a Pepper, right, which is a humanoid robot that we bought. We were early adopters of this type of technology to try to understand the human interaction with robots and how that can basically help the manufacturing environment. But it's a reality, and it's a reality that is actually also very passionate, because to the point that, again, we were talking about in the beginning about education and about the trades. This is not, it's a very enthusiastic and very passionate trade, because it is evolving with time. And nowadays, machine shops are no longer what they used to be back in the 70s, back in the 60s, in the 40s. Nowadays, you go into a CNC machine shop, and everything is super clean, everything is organized with with the methods that we've developed of organization. So it's actually a very clean environment, very, very stimulating environment of work. And as technology comes over, I mean, we see more and more the integration of robots to load and unload parts. We see robots moving material around, and tool cribs around for the next setup. So it's very, very interesting how these new technologies are, and certainly it's going to change the profile of individual that is going to be required to work in this manufacturing environment. Because as you know, we've been working with CSIFLEX on automating, at least collecting the information as things are executed in the floor, so we can gather that information and optimize the processes.
So if we were to bring you to the point in the next segue, our last question really, what would you share with somebody in this generation? Or it doesn't even have to be this generation, somebody who's looking to get started in CNC machining. What would you say would be the things to do?
Well, what could I say? I mean, beyond the things to do, I mean, I think I'm going to say that this trade or this area is an absolute must. It's a passioning area, very stimulating. I mean, I myself, and as you do yourself, even though we have companies and we do other things, I still enjoy myself going to the shop floor and run a CNC machine. Yeah. And because that reward of manufacturing, of making things. And one thing that I would like to bring to our conversation also is that this trade traditionally was more of a man's trade, but it is no longer that case. It's absolutely incredible to see how many women, girls are actually adopting this trade because of all the technology that has been integrated, that has been brought into the field. So, if I was to say, what is it? I mean, I think obviously, if you're a young man or young woman that is looking into a trade, certainly CNC machining, manufacturing is a very passionate one that you will never stop learning, and extremely rewarding, very rewarding. Now, there are some other things that we can talk about, like security. Some people might be afraid of the machines, but the technology has come so far that security is prime in this world. So
I think you're right, bud, and I think you've covered that point. And we're coming close to the end of our podcast, but that hour went by so fast.
Wow, it's already
really when we're passionate about a topic and about an industry, I can see how every couple of weeks we'll be able to talk to people and hopefully get them more enchanted about all the different facets of manufacturing and being able to build things. Just a shout out to some of the people who chimed in. Fence Armor said hello. Hello, Fence Armor. Eric says, hola. Okay, maybe he's sitting in a Mexican restaurant somewhere. Thank you, Eric. And Cam Solutions says hi. And Brian Race said fascinating subjects. So I really appreciate that, Brian. Thank you for chiming in. So for those of you who've left some comments, we appreciate it. If you're going to leave some comments on YouTube or Facebook, Stephanie will certainly look at those after. I'm sure many people will be watching the podcasts down the road. And then they will be on Spotify and Apple, so you can listen in. I'm not sure of the commenting structure in those areas, to be honest with you. Maybe there isn't. But you're always welcome to reach out to us at Cutting Time CNC Podcast, and we'll definitely answer your questions. So I'm going to bring on Stephanie, or maybe Stephanie can bring herself on. She's the co-host, damn it. I'm sure she can figure out how to do that.
I'll put on a sweater because it's cold. So.
Well, I before you pass it on to Steffi, I just wanted to thank you both for putting this together. And obviously, we have a fantastic team. You're certainly, part of it, and again, a very enthusiastic team. People and we're so privileged, me and Al, to have the team that we have behind us. And Steffi, you obviously are fantastic, and thank you for doing all the work that you're doing. Thank you all for inviting me for this first podcast. It was very very interesting. I think it's certainly my first podcast ever, so I don't know exactly how I did, but at the end of the day, the subject is so passionate that we could talk for hours. But I really wanted to thank everybody for the work that you guys put together to make this happen, and I'm looking forward for the interaction with the people in our industry from all the multiple facets that this industry has, and try to stimulate people and young people to come into this trade and enjoy it the way we have enjoyed it from our early days.
Yeah.
It is very interesting. So I'm looking forward for our success on this and bringing more passionate people to talk about subjects. Very, very interesting. Thank you.
Thank you, Luis, for joining us. You'll be back again. And next week we have, not next week, on the 27th, 2 weeks from now, we'll have another one. And what is it called, Stephanie?
It's on the screen. Magic.
Oh, look at that. Digital craftsmanship, navigating the CAD/CAM landscape. Now, our guest speaker at that point is still top secret. We will let you know soon, and we'll make sure we get it invited and all those things that we're going to do. It'll be an exciting one. So it is a very interesting topic because the word navigation makes a lot of sense. At one time, the Earth was flat, apparently. So, at one time the CNC world was flat too. So we've got a lot of stuff to navigate on our next podcast. Thank you everyone for joining us. Really appreciate it. Please follow us. We have an outro, and it will tell you where to follow us and all the rest of that. Did I get everything, Steph, or am I missing anything?
I think you rocked it. Yeah.
Brilliant. Luis, thank you again for joining us. I really appreciate it. Thank you, Steffi.
Thank you, Steffi.
Cheers, guys.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast.
End the stream now?
Do you end the stream, Steffi? Did you end it?
Not yet. I just want to make sure we're all good.
We're all good. Thank you, everyone.
Bye.
Thank you, guys.